Hello everyone, welcome back to another episode of DeepRacer Basics. So today I'm going to talk about logs and how to analyze our logs. So suppose you just finished training a model, right? Here I have a model. I want to, I just finished training it. How do I get to the logs, right? How do I download these things? Well, you notice the menu options have changed since earlier versions of the console. So in 2023, if you want to get the logs, you need to copy the model to S3 first. So go ahead and go to Actions and go to Copy to S3, or from the models list here in the console, you can check whatever model you want to download, and the same thing, copy to S3. Now this is going to take a few minutes, so be patient. Next thing you would do is go to S3 service here in the console and look in the bucket for your model, right? So if you're doing this on the console, again, not student league, but the regular professional league, you're going to go into this particular bucket here, AWS DeepRacer assets. The actual name will be different for you. This is the one that what it looks like for me. You will look for the name of your model. So this is, like a fake model that I did. But anyway, you look for your own model, right? And keep clicking through the folder structure here until you get to this, right? So this is what the model package looks like. The model folder contains the actual model itself, right? You have the reward function that was used. And what we care about are the logs. So if I click on logs, you're going to see folder called training, and here you have the SageMaker logs and the RoboMaker logs. RoboMaker is the actual simulation itself. This is going to have all the information regarding how many steps and what the robot did at each step of the simulation as it drove around the car. It drove the car around the track. Now, this is I wouldn't advise downloading this file and parsing it yourself. Would be a major pain. And so we stay tuned for information on how we would do this. I want to take a quick break and say, okay, if you're training locally, your information will be in a Minio bucket, right? I call it Minio. I don't know. Minio. I don't know. Anyway, Minio is, I guess, the local version of S3. It's installed when you're doing DeepRacer for Cloud on your laptop, or not your laptop, but hopefully not your laptop, on your computer. So it's similar to S3. You can see here I've logged onto the console for Minio, and if I click on Demo 1, which is the example I'm using here locally that I've trained, you see a similar folder structure. And again, there should be information for logs. Notice that there's these folders called 0, 1, 2, 3 that didn't exist in the AWS. That's because I was training with multiple workers to maximize the potential of my Threadripper CPU. So I was training with 4 different workers simultaneously. So in this scenario, you'd have to go into one of those subfolders, go to training SimTrace, and here's all the raw data for that iteration. So let me go over some important terminology. So some important terminology to review. I'm going to be talking about steps, episodes, iterations. You might be wondering, what am I talking about? Let me go through it one by one. So here we have a picture of the track, the reInvent track, with some blue dots on it. These blue dots represent the car position at different steps, right? So right here where my cursor is, that's the very first step. The car is driving counterclockwise. And the next step is about roughly 1/15 of a second. The car is in this position, etc., etc. And you can see the path the car took, and it basically drove right off the track. So this is important because this visualization is useful because you can see what the car is actually doing after training is done. Now, let's go through the terminology. I already mentioned step. That's the snapshot of where the car is every 1/15th of a second. A collection of steps is called an episode. So this is one episode of training. And next, I'm going to show you, okay, this is what it looks like when it actually completes a lap, which is nice. This is what we want. We're going to go from the very beginning where it's just trying different things and driving off the track or crashing, what have you. And eventually we want to get it to complete the track, right? So this is nice. You can see that it's zigzagging and it went off the track here, but not completely. That's why it kept going, right? There was still one wheel still left on this track, so it didn't stop. So this is good, but obviously we want to make that even faster with less zigzag, following an optimal racing line, and that's what the challenge is. All right, so let's continue. What we see here is an iteration. An iteration is a collection of episodes. So in this particular iteration, the car started in different places along the tracks, different starting positions. So it started here and then here and here and here. So you can see that it's doing what's called a round robin approach, where every worker is starting at a certain offset, and that's all configurable when you're doing local training. You can fully customize this, which is really cool. All right, so those are the basic terminology. Make sure you understand that. If you have any questions, just review the sections if you need to use it for reference. Okay, now let's go over how we actually view and analyze these log files. So I'm going to stick to the local training example. I think it's similar if you were doing it to the console. For the console, you would want to download this whole folder, right? You probably want to click here and click on download. In Minio, you basically already have it on your computer. So instead of that, I'm just going to browse to my local hard drive here. Let me do that now. So this is where it resides on my computer. I go to bucket. In this example, I'm going to go to demo 1, right? These are the 4 folders I was telling you about. Let's take a look at this file just for curiosity, right? So you can see there's different iterations. They're all numbered sequentially. And if I open this in, let's say, VI, this is what you get: episodes, steps, X, Y, yaw, steer, throttle, etc., all the information you get at every step, every 1/15th of a second, as I mentioned earlier. Now, this is hard to really read and parse in VI or Vim. You can always look at this in, let's say, Excel or Open Office here. So I guess this makes it a little bit easier to understand what's going on. But at the end of the day, we don't want to do it this way, right? We don't want to reinvent the wheel. I'm going to show you a Python package that the community created that specifically is meant to make log analysis much easier. So let's go right into it. So what you want to do, you want to go to this website in GitHub. The organization is called AWS DeepRacer Community. The repo is DeepRacer Analysis. This is a very nice collection of notebooks, so you can look to understand how your training is going, to understand how evaluation performed, etc., etc. I'll be honest, 99% of my time I'm in the training notebook. I'm not using the other stuff. All right, so how do we install this? You go to code. You copy over here, you copy the URL for git cloning. I assume most people are familiar with this, but just in case, I'll go step by step here for you guys. You're going to download the code using the git clone command. Now you can just retype this or just go to the website and click the button like I did earlier. Now I suggest you use a virtual environment. Everyone using Python should be using virtual environments or Conda environments. You're going to, after you've git cloned the repo, you're going to change the directory into that repo, into that folder, DeepRacer Analysis, and then run the requirements txt file. So you do pip install -r requirements, and it will install I think there's only 2 or 3 packages that it needs. Once that is done, you can run Jupyter Lab from whatever directory you want, right? So you can use, anyway, I'll leave that up to you, wherever you want to launch Jupyter Lab from. So let's go into the notebook itself. So this is, again, I'm focusing on the training analysis notebook. I think it's the best one. Has excellent documentation. Take the time and read through what we have here, right? So again, the authors of this notebook have really nice commentary about what each step of the process is, what the requirements are, et cetera, et cetera. What I walked you through is enough to get going, right? So if you follow my steps, you should be able to use this notebook as is. What's going on here? So yeah, there's some imports. Here's the important thing: getting the logs, right? And here's some instructions on how to get them. I find it a lot easier if you're running Minio locally on your laptop or your computer. Just replace this line of code with the absolute full path to your experiment, right? So once you do that, the rest of the code should run automatically. So let me run through a few things, right? So once it loads the code, it's going to give you information about the hyperparameters and the action space for this particular model build. It gives you, uses pandas to load the data, so you can look at the first 5 rows here. And again, this matches what I showed you in VI and in the Excel file, right? It's the same CSV file. So this tool is going to be aggregating all those individual log files into one data frame for you. So again, use this tool. It makes your life a lot easier. What's also cool is you have access to all the tracks, and you can plot the track, right? So here's a plot of the reInvent track that's used in this example. And you get a collection of charts that are really, really useful. So I'm going to go through the key ones here, right? So this is showing training progress over time, or instead of over time, by iteration, right? As I mentioned before, an iteration is a collection of episodes, right? And what you want to see is this type of increase of reward, increase in time per iteration, and most importantly, increase in mean progress per iteration, right? So the average progress of all the laps, of all the attempts in each iteration. So in this example, you can see that in the beginning, the progress was pretty bad, 10% of the time. Most of the time, on average, the car only made it 10% around the track, right? Which is very understandable, right? It's just learning how to drive, so this makes sense. But over time, it's steadily increasing, and at the end here, we're at 90%. So on average, the episodes in the iteration completed the lap 90% of the time. This is very, very good. This is what you want to see. This is what I call a well-behaved function, right? Because not only is reward increasing monotonically, essentially, as so is progress. So this is really good. All right, let's keep going here. So this is another aggregate view of stats for all your laps. The key thing here I want to show you is the bottom row where it says start at. So in this model build, the car was starting in different positions around the track. So these are the waypoints, the position around the track, right? So you can see it started lots of different places, and on average, time if complete is basically finishing around the same amount of time, no matter where it started on the track. Anyway, so this is a cool chart. Sometimes the car does not do well at a particular starting point, and it's something you want to keep an eye on. All right, so now we get to statistics for complete laps. So I think it's pretty obvious why you want to look at this, right? You want to know how your laps are doing when they actually complete. It might take a while for this chart to actually populate. It obviously won't have anything until you are getting complete laps. What I like to see is the distribution of time. So as you can see here, on average, this model is completing this track in about 15 seconds. Sometimes it's slower, sometimes it's faster, right? And this is what I used to call the lap lottery, right? In the past, you could submit your model to DeepRacer hundreds, maybe thousands of times. And why people were doing that was because they were trying to get the fast lap times, right? So you can see most of the time it's going to be 15 seconds, but if you get lucky, you might get 14-second lap time. So people were submitting hundreds and thousands of times to get that, like get that lucky draw, right? Get that lucky lottery ticket that completed the lap in the fastest amount of time. Now, Amazon has changed the rules in 2023. You only have 50 submissions for the month's qualifier race. So you can't do that. You can't spam the servers anymore. But then again, this view is going to give you an indication of how well or how fast your model is. All right, the last, or I guess the last chart I want to show. I like this chart a lot. This is a quintiles chart. It takes all the iterations that have been completed, and then divides them into 5 buckets. The first bucket here, the first row, is the first 20% of your iterations, and as expected, the progress is not that good, right? Again, it makes sense. You just started training, but look at what happens over time, right? As time goes on, the progress bar starts moving towards the right, the distribution moves towards the right, and now at the end, you're getting a lot of 100% completions. And this is exactly what you want to see, right? So this is a great example of a successful model build. So I like watching this as training is going on. I refresh this notebook regularly to just make sure that that the model is making progress in getting closer to completing laps more consistently. This is super important when you're cloning a model. You sometimes see, oh wow, like I have really good progress in the beginning, and then it gets worse and worse, right? So if you're cloning a model, you definitely want to pay attention to this chart as well. All right, just to wrap this up here, you get all the statistics like, fastest time for the completed data, the completed episodes. You can read through this. It's pretty cool. You get some great statistics here. You can even get a trace of every step that a particular episode undertook. Right, so here I'm looking at episode 10, and it's showing me step by step where the car was, where it was facing, right? Heading is the angle of where the car is facing on the track, the steering angle, the action taken, etc., etc. Super helpful if you're trying to diagnose or debug your reward function. All right, and then you saw these charts earlier, right, where you can plot the actual car positions for a particular iteration right here. So these charts are pretty cool. And finally, I'll finish with this one. This is a heat map of the reward function across all training episodes. So I'm hoping when you look at this, you recognize what type of function this was, right? It should be really clear. The brightest points here are along the center line. That means the reward function had the highest value and then trails off. This is essentially the follow the center line reward function, and it's visualized here as a heat map. So this is pretty cool. It helps you identify where your reward function is giving off, let's say, the highest values and the lowest values. So it may not be what you expect, right? You might be accidentally rewarding or giving high rewards to certain parts of the track where maybe it encourages the car to go off track or something, right? So you want to make sure you take a look at this and that this chart makes sense given what you're trying to do. All right, so let's move on. All right, so I want to show you something else. If you're training locally, you're probably using multiple workers. Like, why wouldn't you, right? You have a good CPU, maybe a gaming desktop. Uh, you can easily have multiple workers. When you do that, you have to make some adjustments. So what I'm showing you is my notebook. I've modified the example training analysis notebook that comes with the repo. I got rid of all the fluff. I got rid of all the explanations because I already know the charts, right? I don't need to read that every time I open this up. So I got rid of all that to make it as streamlined as possible for me. I've also moved the model log directory and the track name settings to the very top because this is the two items you're going to change constantly, right? Whenever you run multiple experiments. The rest of the code, you just hit refresh or run all, but these are the two things you're going to change. So as you can see here, I've hard coded the location of where, the absolute path to where my experiment folder lives in my Minio bucket. The way I've set this up, I'm actually running this from within WSL2 Ubuntu. That's the basically the virtual machine or the Windows subsystem layer for that lets you run Ubuntu within Windows. So I'm running the notebook within there, right? And I've saved my Minio bucket onto my hard drive, my Windows hard drive, basically. So this is why I have this unusual path, which is mounting the external hard drive X, and then the path on that hard drive, right? So I just wanted to explain that in case you found that a little bit unusual. That's how I set up my system. It's super easy. It lets me browse my folders and my files through the Windows Explorer. It avoided a lot of issues I had with Docker and Minio. It's just a nightmare. If you want more information, definitely check out my how to install DeepRacer on Windows video. I go through the steps of how I set up my system. All right, so let's keep going. So what I wanted to highlight is I have multiple workers, right? So you have to make a certain change here. And when the notebook aggregates all the data for all the charts and graphs, you need to add this code right here. Second group equals unique episode. And what this is going to let you do is aggregate at the correct level of detail so that you can get episodes across all the workers you've used. So I use 4 workers here. When you use second group equals unique episode, it knows to go into those subfolders I showed you before. It's all handled automatically for you. Now I want to show you some other trick. I want to make sure you guys know about whenever you have a question and you don't understand what's happening, you can right click, go to show contextual help. It says click on a function to see documentation. I'm going to click over here and it loads up the documentation for this, right? So simulation ag is a utility function from the DeepRacer repo, and this gives you the information that you need to know, right? So you notice second group is here. Second group equals, it defaults to episode. Again, that's if you're only training one worker. If you're doing local training, you're going to want to use multiple workers if you have the horsepower. Believe me, things will go much, much faster. So you want to make sure you change second group from episode to unique episode. All right, and then it'll do all the other aggregations correctly. Otherwise, you're going to see weird times, right? Your lap times will be 4 times or multiple times of what you think it should be because it's basically just adding it naively, right? Okay, so I want to make sure you guys saw that really key thing. So let me just walk through what I have here. So in this example, I let this train for many hours, 140 iterations. This is equivalent to like around 2,000 plus episodes. I mean, tremendous amounts of training. But look what happened. Looks like it's increasing, right? So it's like, but it's very noisy. That could be questionable. And then look at this. After 140 iterations, only the mean progress was 20%. It only made it a fifth around the way around the track. This is not good, right? You can also see the mean reward kind of plateaued, The mean time is all over the place, only 3 seconds. That's pretty terrible, right? It was a very sad day. That's all I'll say. So if you look at the start at, so I was starting in 5 different locations around the track. Progress basically plateaued from the starting line around 25%. When I started little, almost at the end of the track, I made it a little bit further, but again, very pitiful, very bad. And now the quintiles chart. In the beginning, everything was under 20% completion, which is expected. But guess what? It never really changed, right? Look, it's still under 20%. So this was a failure. I wanted to show you this because if you see this happening, you should just stop training and figure out what's wrong with your reward function. All right, so that's basically, let me just end there. Those are the key takeaways. You want to be viewing this progress over time. And what I do is, again, I basically create a new notebook for every experiment that I run. I update the path. I make sure the track name is correct. And I just click this button right here, restart kernel and run all cells. So every hour or so, I click on that, refresh, look at the charts, and then I see how my training is going. Maybe I have to make a change. Maybe I have to abort. Or be like, no, this is dying. This is a complete waste of time. Let me just stop it now, right? So I give you lots of tips here. I hope this was helpful. Deep dive on how to use the training notebooks, how to do your log analysis. And I'll just end on this comment. If you're in the student league, you may be wondering, how do I get this? Unfortunately, you do not have access to logs from models being trained in the console. That's simply how it is. And I'll just say right now, I think most people who are super competitive in student league, they're training locally and then just copy and pasting the reward function into the console and training there for the official submission. I really think that's what people are doing. That's what I did just when I was trying it out last year. So if you have access to a gaming PC, you're in great shape. You can do all this at home, right? If you don't, I don't know what to tell you. Good luck. Maybe it'll work out for you, but it is going to be tough to be competitive at this level without training locally. That's just my personal opinion. All right, well, good luck out there, everyone. Please like and subscribe. It really helps get the word out about the channel. And leave a comment. Let me know what you think. And good luck. See you out there. There you have it, folks. Team Voltron. Stay tuned for more. Make sure to subscribe and click that like button if you want to see more of this content.